Students, in today's session we are going to discuss magnetic properties of solids and corresponding examples. This is very important point for board exam as well as for MCQs. So many MCQs already asked in different entrance exams. So let us start with today's session. So in physics also you came across different magnetic properties of the compounds. Can you tell me what are these magnetic properties? One is diamagnetism, paramagnetism, ferromagnetism, antiferromagnetism and ferrimagnetism. So these are the different phenomena which indicate magnetic properties of the compounds. Now we are starting with first property. Diamagnetism, that is phenomenon and substance known to be diamagnetic. So remember, a phenomenon in which phenomenon we are going to discuss here? Diamagnetism. So phenomenon in which substance is weakly repelled in magnetic field, that phenomenon is called as diamagnetism and that substance is called as diamagnetic substance. So remember here, substance is weakly repelled in which field? Magnetic field. That kind of phenomenon is known to be diamagnetism and substance is known to be diamagnetic. So remember condition, those species which do not have any unpaired electron or those having all electron in paired condition, these gets repelled in magnetic field and that phenomenon is diamagnetism and compound is diamagnetic. So can you tell me one example of diamagnetic substance? Suppose we take this one, scandium plus 3 ion. It is what kind of substance? Diamagnetic. Can you tell me how to explain diamagnetic property of scandium? It is d block element. What about scandium? Atomic number 21. So what we can write? Argon 4s2 3d1. 18 plus 2 20 plus 1 21. What is charge given here? Plus 3. So in order to form scandium plus 3 ion, there is loss of 3 electron. So all these electron gets lost. What remain? There is 3s2 3p6. So there is absence of which electron? Unpaired electron. So it is repelled in magnetic field and it is what kind of species? Diamagnetic species. So remember first one, when species gets repelled in magnetic field, it is called as diamagnetic. This is supposed to be example, scandium plus 3. Now check next phenomenon. What is next phenomenon? Paramagnetism. So reverse word we are going to use here. What is paramagnetism? Phenomenon in which substance is weakly attracted in magnetic field. That phenomenon is called as which one? Paramagnetism. So instead of weakly repelled, it is weakly attracted. That phenomenon is paramagnetism and that species is called as paramagnetic. Now remember here, those species having unpaired electron, these are weakly attracted and these are known to be what type of species? Paramagnetic species. Can you provide at least one example of this one which is weakly attracted due to presence of unpaired electron? Suppose we check this one, manganese plus 2. What about manganese plus 2? Atomic number 25. Atomic number 25 indicate argon 3d5 4s2. Suppose we check different species in this form. This is MnO2. Tell me charges. This is minus 4. So this become plus 4. So how to form Mn plus 4? Mn, what is configuration? 4s2 3d5. So in order to form Mn plus 4 ion, there is loss of 4 electron. How? 2 electron loss from 4s, remaining 2 from 3d. So what about remaining configuration? 3d3. So tell me what happened in case of d orbital? 1 unpaired, 2, 3, 4 and 5. So how many unpaired electrons are there? 3. So it is weakly attracted in magnetic field and it is example of paramagnetic. Now check next phenomenon. What is next phenomenon? Ferromagnetism. Suppose substance is having large number of unpaired electron, it is strongly attracted. Remember this word. Phenomenon in which substance is strongly attracted in magnetic field, that phenomenon is known to be ferromagnetism, and that species is called as ferromagnetic species. What about example of this one? Suppose we take this case, Fe plus 3. Tell me, what is the atomic number of Fe? 26. What about configuration? Argon 4s2 3d6. In order to form Fe plus 3 ion, how many electrons should be lost? 3. So 2 electron lost from 4s, 1 from 3d. So what you are getting here? 3d5. Now check 3d5 configuration. 1, 2, 3, 4, 5. There are how many unpaired electron? 5 unpaired electron. So it is strongly attracted in magnetic field, and that phenomenon become ferromagnetism, and that species is called as ferromagnetic. And remember, in this case, higher the number of unpaired electron, higher will be the paramagnetism, and that is nothing but which phenomenon? Ferromagnetism. Check next one. Antiferromagnetism. What anti indicate? Opposite. So remember, in this case, water may be the species under study. Its magnetic moments are aligned in this form. What this indicate? Magnetic moments of the electron arranged equally. That is, equally distributed in opposite direction. Upward, downward, upward, downward, upward, downward. So these magnetic moments get cancelled with each other. And what happen in this case? Water may be the net magnetic moment. That net magnetic moment is exactly 0. Remember, for MCQ, in antiferromagnetism, what happen? Net magnetic moment of the species is exactly 0. What is the reason behind this? Equal and opposite distribution of magnetic moment. Suppose we take example of this one, antiferromagnetism. Remember this one. What about this? FeO, then MnO. These are indicating what kind of phenomenon? Antiferromagnetism. Now check last one. What is this? Ferrimagnetism. So in this case, according to this alignment, can you tell me? Upward, downward, downward, again upward, then downward. What it indicate? Magnetic moments of the electrons are unequally distributed. These are not equally distributed, unequally distributed. So that what happen? They do not cancel with each other. So net magnetic moment. What happen? Net magnetic moment is not exactly 0. It is not equal to 0. So that phenomenon is ferrimagnetism, and that species is called as ferrimagnetic. Remember, for MCQ, what is example? Fe3O4. This is known to be what kind of species? Ferrimagnetic species. What is responsible factor? Unequal distribution of magnetic moments of the electron, so that net magnetic moment is not equal to 0. So remember what we discussed here? Different phenomena. Diamagnetism. Substance is weakly repelled. There is no presence of unpaired electron. Paramagnetism. Substance is weakly attracted. There is presence of at least one unpaired electron. What about ferromagnetism? Species is having large number of unpaired electron, and it is strongly attracted in magnetic field, and it can be permanently magnetized. That phenomenon become ferromagnetism. What about next one? Antiferromagnetism. Anti means opposite. So what happened in this case? Due to equal and opposite distribution of magnetic moments of electron, net magnetic moment will be exactly 0. And what happened in case of ferrimagnetism? There is unequal distribution of magnetic moments of electron. So net magnetic moment is not equal to 0. That phenomenon is called as ferrimagnetism. We also provide respective examples. Now check next point. What about examples of magnetic properties? What is our question in front of you? Classify the following as diamagnetic, paramagnetic and ferromagnetic. These are the different species. Now we can check one by one. What about this? We have to check one by one. Can you tell me first species known to be nickel? What is the atomic number of nickel? 28. So tell me how to write nickel. Atomic number 28. Argon. What is this? 4s2. 18 plus 2, 20. So this becomes 3d8. What is 3d8 indicate here? 3d8 indicate what type of configuration? Check this one. 1, 2, 3, 4, 5. 4, 5, 6, 7 and 8. What you are getting here? Unpaired electron. So this is what kind of species? Correspondingly species having unpaired electron. Now check this one. What is VO? Can you tell me here? -2, so it become +2. What is the atomic number of vanadium? Scandium 21, titanium 22, vanadium 23. So what we can write here? B23 nothing but argon 4s2, 18 plus 2, 20. What this become? 3d3. Now can you tell me here what happened? In order to form VO plus 2, this V. What is this? 3d3, 4s2. What you are getting here? Formation of V plus 2. There should be loss of 2 electrons. So these 2 electron gets lost. What you are getting? 3d3. There is presence of unpaired electron. So it is found to be paramagnetic in nature. What about next species? Zn plus 2. Can you tell me? What kind of species Zn plus 2 is? Zinc, atomic number 30. Tell me. Configuration is argon. What does this become? 4s2. 18 plus 2, 20. Remaining 3d10. So in order to form Zn plus 2, what should be condition? Zinc having configuration 3d10, 4s2. What kind of charge we require here? Plus 2. So there should be loss of 2 electron. 2 electron loss from 4s. So what remain? 3d10. So tell me how to distribute 3d10. 1, 2, 3, 4, 5. As per Hertz rule, all orbitals are singly filled. Then remaining undergoes pairing. So there is no presence of unpaired electron. All are paired electron. So it is found to be what type of species? Diamagnetic species. Absence of unpaired electron. So in case of next example, tell me what it indicate? Mn plus 4 ion. So what Mn plus 4 ion indicate? This is Mn25. This is argon 4s2. 18 plus 2, 20. So what this become? 3d5. What charge we are expecting here? Plus 4. So tell me Mn having configuration. Which one? 3d5, 4s2. Form Mn plus 4 ion by losing 4 electron. How 4 electrons are lost? 2 from 4s, remaining 2 from 3d. So what remaining configuration you are getting here? 3d3. Tell me what happened in case of 3d orbital? 1, 2, 3. How many unpaired electrons are there? 3. So it is attracted in magnetic field. It is again found to be paramagnetic in nature. What about next species? Cu plus 2. Can you tell me Cu plus 2? What is copper? Atomic number 29. Tell me configuration. This is argon 4s2. So this become 3d9. But in practice it become 4s1. So it become 3d10. 18 plus 10, 28 plus 1, 29. Now tell me what charge is required here? Copper plus 1. So what we can write? Copper 3d10, 4s1. What is charge here? Plus 1. So there is loss of 1 electron, and that electron is lost from which one? 4s. So what remain once again? 3d10. Just to indicate in Zn plus 2, there is also 3d10. So how to distribute 10 electron in 3d orbital? First of all, they are singly filled. 6, 7, 8, 9 and 10. So there is no presence of unpaired electron. It is weakly repelled in magnetic field. So again it is found to be diamagnetic in nature. What about last spaces? Can you tell me directly? Mn plus 2. What is charge on manganese? Plus 2. So tell me how to form Mn plus 2. This is nothing but 4s2 3d5. Tell me what is charge on manganese? Plus 2. So 2 electron from 4s will be lost. What remain? 3d5. So what about 3d5? Tell me distribution. All the 5d orbital possess what type of electron? Unpaired. So there are how many unpaired electron? 5 unpaired electron. So what is our criteria? Higher the number of unpaired electron, species is strongly attracted in magnetic field. It can be permanently magnetized. So it is an example of what kind of species? Ferromagnetic species. Remember, it is strongly attracted and can be permanently magnetized. So whatever may be the species given to you, you can easily classify them into different categories. Now shift towards next point. What is next point in front of you? Identification of highly paramagnetic species. Means ferromagnetic species we are going to discuss here. Can you tell me first case? Mn plus 6, 1 by 1. What about unpaired electron in Mn plus 6? Check this one. This is 3d5 4s2. What charge we require here? Plus 6. So there should be loss of 6 electron. Now tell me 4s2. 2 electron from 4s. Remaining 4 electron from 3d. So what you are getting here? 3d1. What 3d1 indicate? Only one unpaired electron. So what we can write? One unpaired electron. Just you have to focus this value. What about Cr plus 3? Chromium plus 3. What Cr plus 3 we can indicate here? Chromium. Tell me chromium. It is not 4s2, 4s1. So 3d5. What is charge given here? Plus 3. So tell me, in order to form chromium plus 3, there is loss of 3 electrons. How 3 electrons are lost? 1 from 4s, remaining 2 from 3d. So what we can write here? 3d3. Tell me, in case of Cr plus 3, there are how many unpaired electron? 3. So what we can write here? 3 unpaired electron. What we have to identify? Highly paramagnetic species. Means that species should have large number of unpaired electrons. Now check next species. Which one? MNO. Can you tell me here? MNO. In MNO, what happened? This is having -2 charge. So this become +2. So just we wrote Mn here. What we can write? Manganese. What is this? 3d5 4s2. What is charge we are getting here? +2. So tell me, in order to form Mn plus 2, there is loss of 2 electron. These 2 electron lost from 4s. So what remain here? 3d5. Draw block diagram for 3d. 1, 2, 3, 4, 5. How many unpaired electron getting here? 5. So we can write here. How many unpaired? 5 unpaired electron. Check next one. Fe plus 2. Can you tell me directly Fe plus 2? What is Fe? 3d6 4s2. What is charge to be required here? +2. So loss of 2 electron from 4s. Tell me what is configuration? 3d6. Now how to distribute 6 electron in 3d as per Hund's rule? 1, 2, 3, 4, 5, 6. So how many unpaired electrons are there? 4. So it is having how many unpaired? 4. Now check last species. TiO2. TiO2. Can you tell me charge separation here? This is -4. So what Ti become? +4. So how to obtain Ti +4? Scandium 21, titanium 22. So 22 distributed as 4s2 3d2. What is charge we are getting here? +4. So how many electron to be lost here? 4. So that what kind of species you are getting? Ti +4. So 2 electron from 4s, 2 from 3d, loss of 4 electron. What you are getting here? 3d 0, 4s 0. So there is absence of which electron? Unpaired. So what we can write here? There is 0 unpaired electron. Now all the species are explained in detail. What is our criteria? spaces should have large number of unpaired electron, so that it will be highly paramagnetic. So here 0, no question. What about this one? 1 unpaired electron, here 3 unpaired electron, here 4 unpaired electron, this one carries 5 unpaired electron. So which is highly paramagnetic? Mn plus 2 ion. This is highly paramagnetic. Next point, last point, check here. Magnetic moment. So how to calculate magnetic moment? So main MCQs ask upon this particular point, magnetic moment. So remember, mu equal to this one, n in bracket n plus 2. Remember meaning here, where n equal to, what is n equal to? Number of what type of electron? Unpaired electron. So remember, mu nothing but under root n in bracket n plus 2. What n indicate? Number of unpaired electron. So whatever may be the spaces given to you, either in the form of compound or cation, you can calculate number of unpaired electron, put that unpaired electron here, so that you will get which value? Magnetic moment.